So next topic in our statistics is probability. Yesterday we tried to cover this inferential statistics. By this weekend, try guys, it is like 5 questions. There are some 5 questions in the quiz. Kindly request you to I'll reschedule it so that you guys can take.
Good evening, sir.
Good evening. Good evening. Like like see in the last class what I was trying to teach you is like the inferential statistics. Like there are some 5 questions. I request you guys to take those quiz and complete it by this weekend, like Saturday and Sunday. I'll give you the time so that it's pretty simple, you can finish it up. Any doubts, like those who are absent, I'll try to upload all these video classes. And for the benefit of those who are absentees, if they can have the profit, I'll just do it this for this weekend. All the classes, whatever we have. And today, I'm going to teach you is about probability. This probability is a pretty important topic that wherever you go, or whatever business you guys do, probability plays an important role in your decision making. Day-to-day decision also it plays an important role. So let me jump to this topic. Okay. Okay. Let me start about probability. What is the reason? Like, guys, I request you to be a little participative in this class. Uh, like starting from okay, Aditya. Okay. Why you require probability? Any idea of it? We can.
Hello, sir. Am I audible?
Yeah. Very much.
Hello.
Yeah. Audible, man. Audible. We can. Very much
Can you
audible.
repeat, sir?
Like I was asking you, why you require probability? Just whatever you know about probability, you can let me know. It's nothing like it has to be textbookish. Whatever you feel like. So that I just want to start with students' interaction. That's it. Why you require
Okay.
probability?
Okay. So we require probability to confirm whether an event has happened or not.
Hmm.
We can also use it to find out the uncertainty.
Anurag, any idea?
Um, more,
Even
but
anything you can tell. Whatever comes to your brain. See why you require probability.
to find out whether it's raining or not, that's probability of raining, and we can find using some
Devika,
algorithms and all.
Devika, yeah.
Yes, sir.
Why you require probability? Nice.
So
Simple.
to find out whether this event occur or not, like how much probability if this event is going to occur, then how much probability this event have. Like for example, tossing a coin. So probability for head, probability for tail.
Then what is the use of it? We generally guys study this coin tossing, but apart
Yeah.
from it, any usage of it?
To know the possibilities.
Okay, like in the sense like for what? Real-time examples. Real-time examples you can.
Whether a student will pass or fail.
Then next, anything? Whether I'll get selected in an interview or not.
Probability of raining today.
Sorry?
Probability of raining today.
Okay. Anything else? Okay.
If you're not sure about the outcome of the result, that time we can talk about the probability.
See, okay, got it. Guys, any other guys like you want to let you voice out your opinions? Anyone? Abhi, Vinay, Sandhya. I think so. There are a couple of candidates from Yastics who are on leave, I think so, right?
Divya Dalib is absent today.
What? Some names. Okay. See, okay. See, I want to understand the definition goes like this. It's like the likelihood that the event is, what is the chance like this event is going to come as an outcome. So basically what I'm trying to do is like to find a business, to run a business, unless I know the success rate, I cannot invest money, right? So what you try to do is like you look at the probability. Basically, probability gives me what is the success rate or what is the chances, like what outcome it will end up into using the historical data. We are trying to predict it. There's no guarantee for that outcome to really happen, but what is the possibility or chances of it? For this good example, where and all I can use probability. That comes to it. Mostly, we guys do this probability analysis in a marketing data. Market data may, if you try to do this probability, this outcomes will give you a very good result. In the sense, like if you want to do an e-commerce market research, there you use probability, it will be very successful. And even in finance, if you guys are working on credit risk, they use this probability of default. There you can use, that's okay. But never go with healthcare thing. In the sense, like what is the success rate of a doctor? Never do that. Because if that doctor is like in one patient of it, if like where and all I am telling, where and all I should not use probabilities in the case of a doctor. Never say that a doctor is like 100, 99, 95% is the success rate. What is the probability that goes for a default? So these are the places where and all I have to use probability is mostly on the marketing data. This is there is a book called Fooled by Randomness by Nassim Taleb. If you have a chance, try to read it. It gives you a very good example where and all like probability is cheating us, it deceives us. So and where and all I should not use probability. See, since I'm just, it's like more like an introduction class, I'll just tell you. Like everyone will be expecting our business to grow. What in the case of an the tail risk events, in the sense like you already know the Gaussian curve. In the probability in the left hand side, like suddenly because of COVID, some business is we cannot expect those things, right? So never in a probability we can forecast all the variables. So that's a limitation in probability, and this we have to understand in practically. And this how it comes is like through experiences. This probability, like most of the time, our mind goes, it's like what is the success rate? Okay, if you guys are loving like each other, like what is the probability like my love, like love life will turn out to be marriage? Those times we should never do this probability because that is not going to be effective. These are like you have to understand where and all I should use probability and never over utilize this probability theory in all different walks of life. Okay, going to its concept, what is an experiment, what is the outcome, what is sample space, and what is event? I'm going to what are the different, the experiment is like where different outcomes is getting generated, and the outcomes is nothing but the results. Sample space is the what are the different variables. There is output data, like different values that is getting generated is the sample space. And in that, what are the different events that comes is the sample space. Okay. So here, what I'll be trying to do is like what there are a few there is equations or rather formulas. You guys have to memorize it or you have to keep it in your there is for a better understanding to evaluate it. So probability of the like, how many successful outcomes it is coming. So the number of favorable outcomes divided by the total number of possible outcomes. In the sense, what Devika or someone like told me like tossing a coin, right? Like you toss the coin 5 times and 2 times hit comes. So what is the probability event is like 2 out of 5. That is the probability event. Like that, like you can see, or 50-50 chances of it, the what are the events that is coming and what are like a rolling of a dice. Like this, we have to do. Like so, P of E is nothing but number of times the event occurs divided by the number of trials, like 2 out of 5, as what I told you. Then the other thing is like if you don't know any, there are like there is another thing is like the complement of it in the sense alternative of it, like you are trying to build an alternate hypothesis. Similarly here also the complement rule of complement is like every probability sums up to 1. So any factor like all the probabilities if you sum it is equal to 1. So anything like you try to put 2 out of 5, the next time is like 3 out of 5 is the other probability like tail occurrences happen. So this rule you have to keep in mind. Then addition is like A union of B is nothing but A of B plus probability of A plus probability of B and minus probability of A intersection B. This you would have already studied and just running. Okay. Similarly, what and all probability rules we can use is like already discussed in the previous slide. Here is like you can use addition rule, then you can use multiplication rule. So where A plus there is A union of B is nothing but A probability of A plus probability of B. A intersection B is nothing but product of A into product of probability of A into probability of B. Then this is the conditional probability. Each and every some where and all you get like what is the occurrence of events, like a probability of A. There is a at what condition it happens means the A interaction of B by probability of B. This is what you have to do. Where probability of B is greater than 0. This is what you have to do. Okay. Then bias theorem. So this is one of the important theorems you guys you'll be using it, and nothing but probability of A and B is nothing but probability of B intersection A into probability of A by probability of B. Guys, like bias theorem, have you already studied it or like you want me to give further explanations of it? Hello? Hello, guys. Like Anurag,
Yeah.
you want further explanations on bias theorem or like what is it?
Just want to study the formula, I think.
See, any event you are trying to, okay. If you want further explanation, I'm happy to share or like Vani or you let me know. Like, in case you want further explanation, bias theorem.
An event would have already occurred. Using that event,
Ah.
we'll be trying to find the occurrence of another event.
Yeah. So, like anyone else, like you guys already know because of that only, I'm trying to just show the formula. In case like anyone wants a further explanation, you let me know so that I'll again reiterate it. Guys, Vinay, are you comfortable? Vinay, like, guys, are you listening or like?
Yes, sir.
Yeah.
Yes, sir.
Okay. You are comfortable, right? Or like you, or like totally you guys are like, because of the interaction is very less. That's the reason why I'm asking you guys.
No, everyone is listening.
Okay. Okay, guys. Like this is what you have to know. Bias theorem, you have to really whatever you like. நீங்க ஏதாவது ஒரு ப்ராப்ளம் கேட்டாங்கன்னு வச்சுக்கோங்க, probability of B, then you have to this all the three elements you've been knowing it, and through which you'll be able to find probability of B. அதே மாதிரி மாத்தி மாத்தி you have to keep on shifting it, and you have to work on this. This bias theorem or the formula, this PPT, this slide, try to ensure that you take a snapshot of it and use it wherever the calculation is secure. Okay. Similarly, the probability அப்புறமா இதே வந்து discrete distribution, like in the like if you want to estimate like a discrete distribution, in that case I have to use this binomial distribution. So அதுலயே வந்து three varieties இருக்கு: Poisson distribution, binomial distribution. So I'll be trying to explain about this binomial distribution. Then I'll be explaining you about Poisson distribution. Then I'll try to tell you where to use Poisson distribution and where to use discrete distribution. Okay. Uh, so what binomial distribution is like, if you have the number of successes in a fixed number, okay, like then you use this binomial distribution. So இதுக்கு வந்துட்டு ஃபார்முலா என்னன்னா, probability of any event is nothing but total number of events அந்த இதுக்குள்ள what is the probability of k, and what is 1 minus that probability into number of events minus that k function. So you just keep hold of what is binomial distribution's formula. Similarly, Poisson distribution formula is nothing but lambda of k e minus lambda by k factorial. So இங்க வந்துட்டு I'll be trying to tell you, okay, what is a binomial distribution? It's like a fixed number of independent trials each and every time. Okay, if our like in the sense like where to use it, the fixed number of trials. If you already know there's finite number of trials, then you use this binomial distribution when the outcomes is like two possible outcomes, either success or failure. Then you use this again this binomial distribution. Then constant probability of success, like in the sense like there are only two events. அதுல வந்துட்டு you know this is the success rate of one event, like tossing of a coin is constant. Like then you will say, then you use binomial distribution, and at the same time all these events should be independent. It should not influence. Like in that case, you use a binomial distribution, like flipping of a coin, then rolling of a dice, then surveying. And those places you have to use binomial distribution. The formula I have already showed you. And just again showing. Similarly, Poisson distribution is like when you have fixed, like the fixed interval of time, assuming that events will happen in a constant rate. Okay, in the sense like if all the events occur, but at a fixed interval of time. So in that case, like you try to work on rate of occurrence. Here, what is the beauty is like there are only two variables are happening in what in binomial distribution, whereas in Poisson it is more than that. So the rate of occurrence is like fixed is known, and each and every event should be independent, like similar to the previous one, and the other things are rare events and infinite trials. In the sense like there are n number of trials we can do. Okay, and similarly like see. That the probability is 1 or 2. That is within the. Hello? Sorry. See, there in binomial distribution, what happens is like you will be only having two variables, and you will be finding what is the probability of one, or else what is the probability of the other one. Here it is not like this. The number of it is based on the time interval you are trying to find it. So this is like time. If any problem, the probability is discussing about time events. Then you try to use this. That is the place of catch. You have to use this Poisson distribution. Okay, guys. Guys.
Sir, can you repeat again?
Yes, sir.
Yeah. Point is, here in binomial distribution, there are two possible outcomes is there. Okay, keep that in mind. The formula says is like 1 minus p. You already know p of k, that is one probability. The other probability is 1 minus p. Okay. So there you use a binomial distribution, whereas in Poisson distribution, it is nothing but lot of events occur. Okay. And it is based on the time or space. Like in the sense, like within 1 hour, this many things is going to get printed out. Like I have showed you, right? The number of emails that you receive in an hour or any event, time-based event that the question has some time-based events, then you use a Poisson distribution where they are trying to discuss about probability of only two events. So, and through which you are to evaluate, then you use a what? Binomial distribution. அதாவது ஒரு கொஸ்டின்ல உங்களுக்கு டிஸ்ட்ரிபியூஷன் கண்டுபிடிக்கணும்னு வச்சுங்க. There are only two events that these guys are going to discuss. Then you use a binomial distribution. Okay. I'm trying to give you tips and tricks. எப்போ வந்து binomial distribution யூஸ் பண்ணணும், எப்போ வந்துட்டு Poisson distribution யூஸ் பண்ணணும். Okay, I'm just telling. இங்க வந்து two possible outcomes தான் வரும் binomial distributionல. At the same time, Poisson, it's more of time that it will be mentioned. So if any question that is coming on time-based events, then use a Poisson distribution. So the formula for Poisson distribution is lambda of k, exponential of lambda by k factorial. இதுவே இதுக்குன்னா p of k 1 minus p, that is n minus k. That is for binomial distribution. So இது வந்து comparing இந்த ரெண்டு distribution நான் எப்படி binomial distribution என்ன number of trials is fixed. But Poisson வந்து can be large. Any n number of you can do. அதே மாதிரி probability of success வந்துட்டு constant for each and every trial. But for an Poisson distribution, typically probability of success is very minimal. So the formula of is like for lambda is nothing but n into p. Number of events into probability of event is nothing but lambda. இங்க வந்துட்டு Poisson binomial distribution only two events can happen. But whereas in Poisson, it is like many intervals, that are many occurrences of many things. Like there you use a Poisson distribution. Use cases on the fixed trials. இங்க பாத்தீங்கன்னா Poisson distributionல time or space interval பத்தி சொல்லுவாங்க. And example like practical usage is like whenever you want to have like fixed number of counting, use a binomial distribution. Poisson distribution la pathina, if there is something that we are going to discuss about time and space, use a Poisson distribution. Okay, and why this is what dealing with independent trials mother binomial Poisson la vandu time events and constant average. அதுக்கப்புறம் then comes the normal distribution. இப்போ வந்து நம்ம முன்னாடி பார்த்தது என்ன, இந்த டிஸ்ட்ரிபியூஷன்லயே பாத்தீங்கன்னா discrete distribution. இது வந்து discrete distribution. In the sense ஒரு டேட்டால வந்துட்டு if the events are very discrete, there it is subdivided into binomial and Poisson. Whereas if the data is very continuous, every minute it is going to happen and you are capturing data every minute by minute, then what type of distribution I have to use is like there are three types of distribution: normal distribution, exponential distribution, and t-distribution. And the formula for normal distribution is nothing but 1 by sigma of root of 2 power 2 pi into e power x minus mu by the whole square by 2 sigma square. Generally, in the it is more in the academic purpose. I'm trying to tell it to you. But in real time, we don't use this many the continuous distribution and all. We are not using it real time in the data science world. But if you are a statistician, there are chances you can use it. Okay. அதே மாதிரி exponential இது வந்து lambda into e minus lambda of x. That is Poisson, like similar to Poisson thing. And t distribution, similar to that, you have to use this formula. These are the three things like you have to note it. Okay. Okay, guys. Hello.
So
Okay.
Okay.
Yeah. So from this, what you guys understood? The probability, which I was trying to just go with the formulas, but basically, like எங்க இந்த கிளாஸ்ல ஒரு காம்ப்ரிஹென்சிவா ஏதாவது எனக்கு சொல்ல முடியுமா? இது வரைக்கும் I was trying to rush. Can you guys give me this, because probabilities like you already know, and just because of it I'm rushing. Can Anurag or someone, can you just reiterate so that if your guys are misunderstood, I can tell once again. Anurag or Devika, guys.
yes, sir.
Yeah, like can you just comprehend what I told you in this class? It's pretty simple. That's the reason why I'm trying to rush. Or if you want some reiteration, I can.
Okay, sir. At first, we saw probability, like what probability is. Then we just saw the basic formulas in probability. And then we just see the conditional probabilities. After that, we see the Bayes theorem. And then
Bayes theorem,
we see,
Bayes theorem எங்க யூஸ் பண்ணுவீங்க? Like anyone can answer. It's not only
so in
Devika.
that sprinkler, whether to switch on the sprinkler or not based on the specific conditions, on there we can use the Bayes theorem.
Okay. Like if I want to find some other probability, like a probability of
Like
B.
for example, if it is a rainy season, the probability of the probably of rain to occur is higher.
Like, okay, but how will we find it in a formula? Where I will use Bayes theorem is what my question is, right? My question was where I use Bayes theorem.
Like real life examples.
Or based on this equation itself, you can say, if I know a probability of A, then the other three variables I know. Probability of intersection of B and B intersection A, then I'll know probability of A, just trying to shift the formula. Like probability of B. This is the formula where I will be using it. Guys, you are able to see this one? I'm showing you in the pointer.
Yes,
So
sir.
why I'm using it? See, half of the time they'll ask you what is the probability of one of the events given like all other factors. Then you use the Bayes theorem. So this is the primary thing. Okay. After which, Devika, you please continue.
And then we saw the discrete distributions, binomial distribution, which is independent Bernoulli trials. And then we saw Poisson distribution, which is independent of time and space, I guess, fixed interval
Yes.
of time or space. After that,
Yes.
we saw the continuous distributions.
Yeah,
which
one
is-
minute.
Yeah.
This comes in discrete distribution, binomial distribution, Poisson distribution comes. Okay. This is like in discrete, keep that in mind. In discrete, binomial and Poisson comes into play. Whereas in continuous,
we have normal
it is a normal distribution,
exponential,
exponential, and
T
T distribution. Okay. And then this discrete distribution, what I further discuss is about the binomial and Poisson. And this tabulation you keep in mind, like whenever there are two values they are trying to give in a problem statement, you use a binomial thing. If the events are large, if the trials are large, then you use a Poisson distribution, and outcomes of this trial will be in two, like only the in any like tossing of a coin, it's either it's success like heads or tails. Similarly, any success or failure, then you use a binomial thing. Whereas in Poisson, there are many occurrences, many values are coming. So for an probability of any event, success is nothing but for n into p is equal to lambda. That is the formula. So wherever they give this formula of lambda, then think that we have to use a Poisson distribution. If they give the probability of one event and asking the probability of other event, then use a binomial distribution. Yeah. This is what you guys need to remember in any exam point of view or any quiz or any activities you have to. That is, you guys are any problem that is coming on probability. They'll touch about Poisson distribution. They'll touch about binomial distribution. Based on the problem, you have to understand where to use which one. And the formula for Poisson is this, and formula for binomial is this one. Okay. Yeah. This this will cover probability. What I'll do in the next class is like I'll try to work on some problem statements and using like I'll take some examples in probability, real-time examples. I'll try to explain you each and every using and you guys will need to solve. Like I'll try to take some 10 to 11 questions for each and every one. Once you see that question, each one has to answer it based on the class what I taught you. Is that fine, guys?
Yeah, fine.
இந்த பிபிடி மட்டும் ஒரு தடவை பார்த்துருங்க. Okay, I'll stop this video.
PPT.